Alrighty. This is a special edition of ScioSophia. Today I'm not asking a particular question. I am, at special request of the audience, reviewing a particular article that was sent to me that appeared recently in the Epoch Times. And I will point out this is an op-ed article. This is not a news article, but making commentary here on why has global warming disappeared. So we'll get into that. Welcome back to ScioSophia, your home for raw, unfiltered, informal science. I'm Adrian, climate scientist, crafter, amateur philosopher. Good to be with you all. And this one does fall very much into my field of expertise. So this was an interesting read for me, and a lot of things I find concerning about this particular article. I'm going to attempt to stay away actually from the politics part of it, because there's actually a significant number of things that the author either got wrong or I found to be incredibly misleading when I was reviewing this particular article. And so we're going to get into that. And I will point out there is a difference between the politics and the science, and sometimes the politics is in line with the science and sometimes it isn't. That's why I'm tending to focus this a little bit more on the science. So let's go through this article. And I've got a whole bunch of other things here to help us review the commentary here alongside of this. This is from Cheng Zhang Nong, and I apologize if I am mispronouncing your name on that, but we'll get there. So let's see. After Joe Biden entered the White House, he created a position that had never before existed in the history of the White House, the climate envoy. Climate policy was elevated to a level of unprecedented importance by Biden and the forces behind him. Why is climate policy so important to leftist politicians? In recent years, the climate policies of the United States and the European Union countries have all come from the same hypothesis, namely global warming. Several years ago, global warming was almost a scientifically unquestionable conclusion, but in the past few years, the global warming hypothesis has disappeared from a variety of documents, slogans, and propaganda of government climate policies in those countries that advocated it before. What's wrong with the global warming hypothesis, and what does its disappearance mean? If you try to analyze the past and present of climate policies of various countries, you'll come to understand why global warming has disappeared. Okay. For fractional matter, in terms of the physical phenomena of global warming, no, it hasn't disappeared in here. And the gentleman here is being a little disingenuous in saying that global warming itself has not disappeared. And I think in one way it comes from his he has a misunderstanding, I think, here of what global warming is and what climate change is. They are not actually considered to be the same thing amongst the scientific community and experts and what have you. They are often used interchangeably, which is a bad thing. Without giving things, this is like fun fact about me. I told off a communications professor in my midterm exam when I was in my PhD program because he kept using them interchangeably and kept pissing me off. So let me show you. So this comes from the Intergovernmental Panel on Climate Change. They have their lovely collection of glossary information here that is really quite useful if you're looking to get into all of that. And they actually have it right here. And the first thing I point out is what climate itself is. Climate, in a narrow sense, is usually defined as the average weather, or more rigorously, the statistical description in terms of the mean and variability of relevant quantities over a period of time ranging from months to thousands or millions of years. Classical period for averaging these variables is 30 years as defined by the World Meteorological Organization. True. The relevant quantities are often surface variables such as temperature, precipitation, and wind. Climate, in a wider sense, is the state, including the statistical description of the climate system. Circular definitions that I hate there, but this is a point to make about the difference between weather and climate, and we'll end up coming back to this. Climate is very much about averages, average high temperature, average low temperature, things like that. It's also very much about what is the frequency of extreme events. How often do they occur? What is the typical placement of weather systems and patterns? How often do they occur? How intense are they? Things like that. Climate change refers to the change in state of the climate that can be identified by changes in the mean and or variability of its properties. Climate does not just include descriptions. When we're talking about climate, doesn't just include the mean, includes the variability, which is why we get frequency of extremes, but also the average intensity of those extremes. that persist for an extended period, typically decades or longer. Climate change may be due to natural internal processes or external forcing, such as modulation of solar cycles, and persistent anthropogenic changes in the composition of the atmosphere or in land use. And that anthropogenic part is just the fancy way of saying humans. Just go there. Down further, though, they have the definition that they use for global warming. But remember what I just said, climate in this definition, and the definition that we use, is about more than just temperature. And that's one of the reasons why there's been a shift in language from using climate change to global warming. From using global warming to going to climate change, is because global warming is the gradual increase observed or projected in global surface temperature as one of the consequences of radiative forcing caused by anthropogenic emissions, which is to say, adding more heat-trapping gases to the atmosphere is increasing the amount of infrared energy kept close to the atmosphere, that kind of thing. But here's the thing with that. That's all about temperature. Climate, as we describe it, is a lot more than temperature. But the fact of the matter is, adding gases to the atmosphere, adding more heat-trapping gases to the atmosphere does increase the temperature, but the temperature also plays a bit into the placement of different weather systems, into the amount of precipitation you can have in different areas, and the like. And that's the reason for a lot of that change, is that there's been people catching up to the idea that, oh, yes, adding more gases like CO2 to the atmosphere does cause more warming to happen, does cause the temperature to get warmer, but it doesn't just do that. So the idea of global warming is specific to temperature, but we realize that doing the amount of global warming that has happened is contributing to changing the climate as a whole. And that climate as a whole includes changing wind patterns and precipitation patterns and moisture patterns, where do fronts end up, where do things, all those kinds of things end up. So there is a reason for that difference. In that reality, hey, climate change is more than just temperature. And we can't talk about it as just temperature. So it's a little bit disingenuous to say that global warming has disappeared as a hypothesis. It has not. In fact, it might be considered one of the driving things behind climate change. Hit or miss some days with the sound mixer here. I apologize. We'll fix that in post. So, on the origins of the global warming hypothesis, what exactly is global warming? Wikipedia explains it as follows. Climate change includes both This is why he shouldn't go to Wikipedia. This is why journalists piss me off. There's a lot better things to look at. I just showed you an example. There's a lot better things to look at than Wikipedia. You dumbass. Straight off the gate, I'm going to say it. I'm pissed. There's a lot better things than Wikipedia. And no, actually, there is data behind this. There's actually about 150 years of information and data. If you read this lovely book, The Discovery of Global Warming, it actually lays it out very nicely, everything and all the discoveries that led up to the idea. And the idea that humans could actually influence the climate, or I should say, human activities can cause an increase in global average temperature via the addition of more heat-trapping gases, or greenhouse gases, if you will. That's been around as an item we've known about for about 150 years. So no, actually this has been around and is a lot older than that. The Epoch Times ignores it, or this author writing for the Epoch Times ignores it. So let's go. Earth's surface temperature is always changing. Temperature change is usually fluctuating, and there are natural climate cycles. Each cycle may last several decades or even millions of years. Fluctuation of surface temperature may be regional, global. And the factors causing these changes are multitude, mostly natural factors, including solar radiation changes to Earth's orbit, continental drift changes in ocean currents, and orogenic movements. These natural factors are beyond our control. Of course, changes in surface temperature may also be related to human activities, such as greenhouse gas emissions. Yeah, okay, that's actually not an unfair statement. Framing-wise, it could be better with that, because he's trying to frame it in a particular way, I think. However, if we attribute all the changes in surface temperature to human activities, or exaggerate short-term changes in temperature as permanent, irreversible changes, and interpret temperature fluctuations as a linear trend, it would be seriously misleading. Okay. I saw this a lot in the article. I did read this through before starting to comment on this. He makes a good run of confusing long-term trends and natural variability. And the same thing, usually when a good way to think about what we're dealing with when we talk about climate change is to think about maybe you own a dog and you're walking him on a leash, but he's not very well trained. So he's darting everywhere, sniffing things, running up to other dogs, all the kinds of things. But because he's on the leash, he's always going to go in the general direction that you are walking. The kind of natural variability of year to year and even sometimes decade to decade variability, that's the dog running. What we're more interested in the climate is where is the person going? And the person doesn't necessarily have to have a linear trend in that, just walking straight up like this or something like that. No, they may be moving around a little bit and what have you in there. And partly that might be the issue of averaging, but that's what we're more concerned about. Is where is the person going, not where is the dog going. And so there is often some confusion there of like what is natural variability versus what we're looking at and more interested in with the longer term changes in climate that is usually multiple decades to centuries and longer is when we're talking about serious climate change. That's what we're more concerned about most often. And so he's right that you should not necessarily, land-based things onto one thing, although current issues with climate change can be very, very well traced to human activity. And there's a myriad of studies and data now to back that up. But he does have a point, short-term changes, when you're looking at things going on from one decade to another, that's not necessarily human caused. That's not necessarily the case. He does have that point, right? But he also tries to mislead a lot when he's talking about natural variability versus long-term trends in here. He doesn't make that very clear distinction when I was reading through this. As for natural factors that affect the surface temperature, first of all, the drift of the continental plates will cause changes in location and surface area of land and ocean, thus affecting the global atmospheric circulation, resulting in global or regional temperature changes. This is false. Straight up. That statement is false. The placement of the continental plates themselves and location of landmass does not determine global atmospheric circulation. I will give you a good example of that right now. I got to find the right tab. I had it. Here it is. This comes from the University Corporation for Atmospheric Research, which is the guiding entity behind the National Centers for Atmospheric Research. And this is a great toolkit here if you want some really serious information about why the atmospheric circulation is, and a lot of other things too. You can see here they got their whole how weather works in the learning zone and what have you. Great little things in here to talk about that at a very base level. But the reason I want to bring this up is because the author of that Epoch Times piece is saying, no, continental shifts and things like that cause atmospheric circulation. For one thing, he has no source. For another thing, that's not true. In here, this has been well established for a very long time. One of the primary reason the atmospheric circulation exists is because the Earth doesn't heat, the sun doesn't heat the Earth everywhere evenly. The most heat that we get on Earth is at the equator, and the least amount of heat coming from the sun is at the poles. And the atmospheric circulation itself primarily exists in an attempt to rebalance all of that, taking the heat from the equator and moving it to the poles and moving the cold air from the poles to the equator and vice versa, and that kind of arrangement. The other reason the atmospheric circulation exists is because the Earth is spinning. So this is a great graphic. Let me see if I can't blow this up. This is a great graphic, actually, that shows the atmospheric circulation. So you get lots of heat from the sun right here. Causes, in general, a lifting motion because warm air tends to rise in here. It cools down, it moves to the north, and it comes back down. In the same breath, you have another cell here that also does something similar. So there's generally like rising motion right here. There's sinking motion right in this area. Rising motion again up here, and sinking motion at the poles. And that goes around both ways, really. One of the other things that happens, though, that contributes to the circulation is the spin of the Earth. So because of that, we have what's called the Coriolis force. And the Coriolis force is effectively the extra force that is applied just because of the spin of the Earth. So basically, and this is something they discovered in World War II when they were firing off missiles, is they were shooting a missile and it would end up very far away from where they shot it at, and this was because of the spin of the Earth. They didn't account for it at the time. So the Coriolis force became a big deal in World War II, and wars shortly thereafter. But the Coriolis force basically makes something move to the right of the motion. So, like, you can see at the surface, it's going this way, going southward generally in the larger scale circulation. One of the things that happens because of the Coriolis force, the spin of the Earth having an act on that, is that the surface level winds are also moving around the equator level anyway, also moving. They're westerlies, I should say. No, I'm sorry. They're easterlies. Easterlies. I get them backwards sometimes. Easterlies, meaning these winds are coming from the east and moving to the west along this particular area. And so that's contributed to by the spin of the Earth. Notice what I'm saying here. None of that happens because of the placement of the continents. That entirely happens because the atmosphere is attempting to rebalance temperature from the sun. So that Epoch Times article is incredibly incorrect in what it's saying about why the global atmospheric circulation is where it is. It's also very incorrect about why a lot of regional circulations is the way they are. In here, because one of the other things it's not on this graphic, but one of the other things that a lot of these kinds of cells contribute to, and I believe there are different names for each of these cells, but one of the things that shows up with these cells is the jet stream. So actually, there's one jet stream right here that goes along, as you might notice, this particular area of the Earth. You remember that jet stream that brings us a lot of fronts and weather systems and what have you? That's actually one of the things that comes from, is the boundary of hot and cold here. And you have another one that's up here that goes in the other direction. That's the polar vortex, if you might remember, might be related to that in here. And you have similar kinds of things along in the southern hemisphere too. But a lot of those jets come from where those cells interact. But those cells aren't there because of the continental shelf or anything like that. And we'll see it in a second. Mountains and what have you do have an impact on where precipitation is and the flow of wind and what have you, and what goes on with different weather systems in the United States and across the world. But it does not have an impact on the global circulation. That is an incorrect statement on the part of the author, which is disappointing. He could have done better with that had he taken a hot second to actually go look up some of this information before he started. And so he annoyed the heck out of me just on that particular field. Second, the orogenic movement of the Earth's crust may form mountains or valleys, and changes in topography will cause precipitation in the terrain and even the formation of alpine glaciers. So, to a degree, that's correct. Because, for example, what happens in the United States often is that when a system comes ashore, it runs immediately into the Rockies. The Rockies forces the air to rise, causing clouds to form, and you get lots of rain and snow over the mountains. And then as you come down on the other side, all that moisture has been taken out. So that's where the Santa Ana winds come from, is they come down moist and dry and come down the mountains really, really fast here, and can cause some problems. So yeah, that is not incorrect. Those at the same time, though, very local effects for the most part. They don't actually influence larger scale changes across larger scale climate across the continent all that much. They definitely don't influence the global circulation all that much. They're very local phenomena. Very small scale local phenomena is also the things like in Puerto Rico. Puerto Rico, which gets easterly winds, has a mountain ridge in the middle that actually interacts with the winds in that area and causes more precipitation to happen on the north side of the island and less precipitation on the south side of the island. It's a very well-known feature because the way the winds form over the island creates a rising motion on the north side and a sinking motion on the south side, and hence you have rain on one side and dry on the other. And it's over a very short distance. It's something like 50 miles. So no, that's not impossible. But one thing I would point out is a lot of the formation of these kinds of things, multiple thousands of years or more. Geologic timescales are actually a lot longer than what we look at for atmospheric timescales and related things there. So those mountains in our lifetime, where they are currently, they're probably not going to move in our lifetime. Could be wrong, but those are a lot longer timescales in here. Thirdly, the sun is the most important external source of energy for the Earth. The sun's activities will affect the Earth's surface temperature in its short-term radiation fluctuations, such as sunspot activity, with an 11-year cycle and radiation change with a cycle of 20 plus years, all have an impact on the Earth's climate. The changes in sunspots with an 11-year cycle will induce change of 1.5 degrees Celsius of the Earth's stratospheric temperature, making high latitudes colder and low latitudes hotter. Based on observations and temperatures changes from 1900 to 1950, this was likely the cause of the Little Ice Age. Okay. Again, he is getting very he's from the start, he didn't really give you a distinction of the longer term climate change things that we're concerned about. The other thing is there. Yeah. He did this with this one and the next one, and I'm struggling for a good way to say this, but he's conflating natural variability and the long-term anthropogenic changes. No climate scientist I know would deny that the sunspot cycle exists. No climate scientist I know would deny that El Nino exists, which he talks about down here. But those things are much smaller scale, time-wise, patterns. The 11-year cycle is all of a decade. We know about that. We know it's natural, and it's not there. And despite what you may have heard, a lot of the modeling world actually that I usually live in, we do take these things into account. We do calculate them. They're all well known, and we can fit them into the models and account for these things. We do, and we do account for them when we're looking at observation data too. It's just like, oh, we can pick out when a volcano erupted. We can account for these things. It happens all the time. So he's being a little disingenuous and not mentioning it, and trying to conflate natural variability and the longer term cycle of climate change in here. And let me go down here. Yeah, because so far this, okay, well, let me go back first. In here, so he's going and conflating that. And this is actually where I want to bring in the point here. Skeptical science is a really great place to go when you're talking about some of these kinds of things, because some people do want to say, hey, it's the sun. Hey, it's El Nino. Hey, it's this. Hey, it's that. And there is actually a lot in here where they talk about, what the supposed myth is, but also why we know that that's a myth. And that's one of the things we talk about with solar activity. And it's a good point to be made here is that he's not making his own point, because he's at the same time as he's trying to say, well, some of this should be human. Some of this is probably human, but most of it should be natural. But then he's trying to come back and say, well, a lot of this stuff is really natural, is kind of what it feels like he's framing. And maybe I'm misreading it, but this is a good example from skeptical science, where it's talking about, hey, it's the sun that's causing all of this. And the truth is, it has been a lot more like this, because this is the solar irradiance by which one measures the influence of the sun. And that really has gone like this direction. But this is actually the same 11-year anomaly with temperature. So no, the sun doesn't explain all of it. And actually, I think, down here, this is a great graphic. And this is to my point. Again, we do try very hard to take into account all of these different things that are natural and piece it apart from what is the actual, what is the human component that contributes to all of this. We do very diligently try to peel these things apart and make sure we know which is which and which is contributing to what we've seen here. And, this is a great graphic. I think he pulled it from, they pulled it, I should say, from the Intergovernmental Panel on Climate Change's 5th assessment report. So fairly recent, at least in terms of reporting kind of stuff. And so this is global surface temperature. And the black line behind here is the raw temperature data itself. And this is sort of averaged, I think what is it? Global temperature. The black line model of global temperature change produced using the sum of impacts of temperature of natural and anthropogenic factors. So what this graphic is this is their estimate. The red line is their estimate of global surface temperature anomalies, which is to say the difference from sort of a normal period. And this red line is based on their modeling using observations. So this is not a climate model itself. This is observations in which they statistically composed everything back together again to see if they could get the same temperature here as what they have. And you can see it's actually pretty damn close. Come to think of it, it is pretty damn close here. Not perfect, of course not. It's not perfect, but it is pretty damn close. And it's one of the things, this is what they accounted for. This is the solar component contribution of the global surface temperature estimated with the solar component, volcanic component. Of course, what you can see here with the volcanic component is, every time there's a big eruption, things drop. Internal variability, this is where we get to things like the El Nino Southern Oscillation and all those natural climatic oscillations that do exist. They're represented in here and their contribution. And this is the anthropogenic component here, which is to say human action in here is what they estimate this as. And so, we do actually account for these things. And I would make a point to point people back to this graphic, because this is a good example of we do our damnedest to account for these things. And a lot of this you can see how big the sort of natural variability component is here. And this is 1 decade to another decade right here, what's going on. So it can be really confusing, and all of that is still going on. But what you need to remember is that this kind of stuff is overlaid on this. And that's why you get back to this kind of graphic where it looks like that. So we do try very hard to keep these things into account. Unfortunately, I think the author in question is actually ignoring all of this when he's talking about it, which is disappointing, because it's not hard to find necessarily in here. But again, this is an op-ed piece, so I'm not necessarily expecting him to go find it, as much as saying his opinion, and I have the right to rip it apart. And I'm going to. So far, the scientific community has very limited knowledge of how these natural factors affect climate change, and scientists cannot describe or explain them clearly. If you saw the other graphic that I just showed you just now, that statement is not true. However, because temperature changes can be measured easily on the surface of the Earth, some people focus on the study of surface temperature records while ignoring the influence of all natural factors and use carbon dioxide emissions to explain the short-term temperature changes on Earth, which leads to the global warming hypothesis. No, actually, it doesn't lead to the global warming hypothesis at all. Like I said, there's 150 odd years behind it. And in fact, I think I'll go to the timeline in a second that I found. Handy, wonderful timeline graphic. So if you don't want to read this book, you can look at that graphic, look at that timeline thing that the National Centers for Atmospheric Research put together, or the University Corporation for Atmospheric Research, one of the two of them put that together. And here, however, because temperature changes can be measured easily on the surface of the Earth, some people focus on the study of surface temperature records while ignoring the influence of all natural factors and use carbon dioxide emissions to explain short-term temperature changes on Earth. First thing, what is short-term? He's not saying what that is here. For me, short-term might be 10 or 20 or 30 years. For him, short-term, I have no idea. He gives me no distinction on that one, so that's a problem right here with that. Okay. Yes, surface temperature records do naturally reflect our measurements. They reflect natural and human influences. So this is the thing that he's ignoring here, is that we do very much try. Where's the graphic again? We do very much try to break this apart, because this thing here, this black line underneath here, that comes from aggregated measurements of temperature. That black line comes from the aggregated measurements of temperature that we have from different parts of the world. And we're trying to break it apart. So I call bull on that one. I call bull on this gentleman here, saying that we can't do that. No, we actually do try very hard to do that, and we do not ignore the influence of all natural factors and use only carbon dioxide emissions to explain short-term temperature changes. No, I'm sorry, that does not happen. This gentleman is incorrect here. And let's see. Okay, I'm not going to get into some of the stuff with the EU and the IPCC and what have you, because some of the predictions that come up here and what have you, we make crapshoot predictions. They do happen. I'm sorry, they really do in here, and I'm not going to get into all of that with the politics side of thing. But I do want to make one more point related to, where's the timeline? Related to climate science research here. And honest to goodness, the basic fundamentals of my field of climate science do go very far back. So the idea of carbon dioxide even existing goes all the way back to 1640. Johann Baptista van Helmholtz from the Flemish alchemists determined that what the atmosphere was made of. He was the first one to start looking at, hey, well, the atmosphere is actually made of this, this, and this, and this. All those kinds of things there. And this is a great little toolkit here where you can just go clicking through and walking through history. But first carbon dioxide detector, there's the Industrial Revolution, describing Earth's atmosphere as a greenhouse. So this goes all the way back. So the idea of there being a greenhouse effect to begin with goes back to 1824. Joseph Fourier, French mathematician, was the first one to really describe how the Earth's atmosphere could retain warmth, how it could work. He didn't have the tools then to be able to figure it out, but he had a very good theory. And actually, in here in the book, in the first chapter, talks about Fourier. Early in the 19th century, the French scientist Joseph Fourier had asked himself a question. It was a deceptively simple question of a sort that physics theory was just then beginning to learn how to attack. What determines the average temperature of a planet like Earth? When light from the sun strikes the Earth's surface and warms it up, why doesn't the planet keep heating up until it is as hot as the sun itself? Fourier's answer was that the heated surface emits invisible infrared radiation which carries the heat energy away into space. But when he calculated the effect with his new theoretical tools, he got a temperature well below freezing, much colder than the actual Earth. The difference, Fourier recognized, was due to the Earth's atmosphere, which somehow keeps some of the heat radiation in. He tried to explain this by comparing the Earth with its covering of air to a box covered with a pane of glass. The box's interior warms up when sunlight enters and the heat cannot escape. The explanation sounded plausible, and by Guy Callender's time in 1938, a few scientists have begun to speak of a greenhouse effect that keeps the Earth from freezing. It is a misnomer, for real greenhouses stay warm through their own reasons. Main effect of the glass is to keep the air heated by sun-warmed surfaces from wafting away. So it's a little bit different. Greenhouse effect isn't quite the most accurate way to look at it. As Fourier recognized, the way the atmosphere holds in heat on the entire Earth is more subtle. The atmosphere's trick is to intercept a part of the infrared radiation from the surface, preventing it from escaping to space. So that's where we actually start. We actually start in the early 1800s with the whole idea that you could have a greenhouse effect to begin with, and figuring out how the Earth works. And a lot of the history of climate science, which again goes back to the early 1800s and some of its earliest formulations, and even earlier with some of its components, we had this idea together already. It wasn't a new idea at all. The correct reasoning, actually, when we get into the idea of humans could end up adding greenhouse gases to the atmosphere and causing a problem, came later with, let me zoom in a little bit here, came later in time with Eunice Foote, I should say, who was an American scientist, in here, and she posited the idea that carbon dioxide and water vapor can cause air to warm in sunlight. Carbon dioxide and water vapor are both themselves greenhouse gases, and that discovery that they could do so actually did happen in a laboratory in 1859. In Britain, this was John Tyndall, who actually did that test. So let me read a little more from the book here. The correct reasoning was first explained lucidly by a British scientist, John Tyndall. Tyndall pondered how the atmosphere might control the Earth's temperature, but he was stymied by the opinion held by most scientists at the time that all gases are transparent to infrared radiation. In 1859, he decided to check this out in his laboratory. He confirmed that the main gases in the atmosphere, oxygen and nitrogen, which together, they're more than 98% of the gases in the atmosphere, if I remember correctly. He confirmed the main gases in the atmosphere, oxygen and nitrogen, are indeed transparent. He was ready to quit when he thought to try coal gas. This gas, produced by heating coal and used for lighting, was piped into his laboratory. He found that, for heat rays, the gas was as opaque as a plank of wood. Thus, the Industrial Revolution, intruding into Tyndall's laboratory in the form of a gas jet, declared its significance for the planet's heat balance. Tyndall went on to try other gases, and he found that the gas carbon dioxide was likewise opaque, what we would now call a greenhouse gas. So that was 1859, when the whole idea of a greenhouse gas came in here. A bit of CO2 is found in the Earth's atmosphere, and although it is only a few parts in 10,000, Tyndall saw how it could bring warming. Just as a sheet of paper will block more light than an entire clear pool of water, so the trace of carbon dioxide altered the balance of heat radiation through the entire atmosphere. Much of the infrared radiation rising from the surface is absorbed by carbon dioxide in the air. The heat energy is transferred into the air itself rather than escaping into space. Not only is the air warmed, but also some of the energy trapped in the atmosphere is radiated back to the surface and warms it. Thus, the temperature of the Earth is maintained at a higher level than it would be without CO2. Tyndall put it neatly, quote, "As a dam built across a river causes a local deepening of the stream, so our atmosphere, thrown as a barrier across the terrestrial rays, produces a local heightening of the temperature at the Earth's surface." So, where this actually came from, it's a really amazing history, where this actually came from, and a lot of the reasons for the study and discoveries around global warming and climate change that lead to what we know today, is the idea that, we want to figure out how the hell the ice ages happened. Was where it actually came from, because by the early 1800s, we'd figured out that the ice ages were a real thing. And so Tyndall was actually getting into this because he wanted to know, hey, how does this actually work? And it keeps on going, because there's actually more here. Svante Arrhenius actually did that too, in that he was the first one to talk about the idea that, the Svante Arrhenius in Stockholm in Sweden, he talked very much about the idea that adding more CO2 could cause a great impact, but also that reducing CO2 suddenly or somehow could also cause that impact with the change in temperatures. And his thought was, if you remove CO2 from the atmosphere or remove greenhouse gases from the atmosphere, the atmosphere will hold less water vapor, and that will cause a positive feedback loop that leads into an ice age. And the same can happen in the other direction also with water vapor and lots of high temperature. And Arrhenius was so dedicated that he ended up divorced and losing custody of his kids because he went after it so much. And so it was an interesting thing with Arrhenius. Arrhenius was really one of the big ones to launch into the idea that it could be possible to add enough CO2 to the atmosphere to warm things up significantly, but also to remove enough CO2 to cool things down significantly. And it was in the early 1930s or so when we started getting more and more people, like some folks who had been around for what have you. So Guy Callender here in 1938, he was the first one to really stand in front. He had the audacity in 38 to stand in front of the Royal Meteorological Society in London and talk about the climate. He was not a meteorologist. He was not a climatologist. He was an engineer, actually. And he had done the first really comprehensive review of CO2 and the Earth's temperatures, with as much data as he could get his hands on. And he was the first one, really, to argue that, yes, human beings and industry producing a lot of CO2 can have a profound impact on the climate. So the whole idea of global warming and climate change has been around for a very long time, and we very soon will be reaching the 100th birthday of some of these incredible findings that led to what we know today with respect to climate change. And so I want to make that point, because people think this is a really new thing just because of the media hype and what have you, but it is really not. We have a very long history with respect to some of the stuff that I do in here. And here's another good example. The first attempts at modeling the atmosphere, in National Centers for Atmospheric Research, Kashabara in Washington, the first of the climate models that existed way back when here. And I think dwindling Arctic sea ice. Yep. No, and there's all sorts of these different things here. Roger Revelle talks about it, and there's huge amounts of things that goes on. And like I said, the reason there's been a lot of transition to talking about climate and climate change instead of just global warming is the understanding that with temperature, that's only one measure of what the climate is and does. But changing and increasing the temperature does also have a profound impact on other parts of the climate. And here's a good example of why. It's a well-known phenomenon, well-known equation in meteorology that's called the Clausius-Clapeyron equation. And what it basically says is that as you warm the atmosphere can hold more water vapor itself. And water vapor is also a very potent greenhouse gas, even though it doesn't stay in the atmosphere very long typically. But the idea under a changing climate is the atmosphere gets warmer, you then have an increase in the amount of water vapor that can be held. It takes longer then for a place to reach saturation. And when you reach saturation, that water vapor condenses into water droplets, which forms clouds and then forms rain. It's very actually established that the idea that as the atmosphere warms, one of the things that can happen is the notion that it will take longer for the atmosphere to reach saturation. Therefore, you have less rain days, more time between rain events. But at the same time, when it starts raining, because the atmosphere is warmer, it can hold more moisture. More moisture can then be rained out. And this is what they actually talked about with respect to Hurricane Harvey and why Harvey was so deadly. It wasn't just the placement. Harvey was deadly because of the placement, and that was more of a weather thing than a climate thing, or at least I think so. I haven't seen a study yet to say that the placement of Harvey had to do with climate change. But the idea with Harvey is that had Harvey happened 100 years ago, there's studies that have been shown that they think the idea is that it wouldn't have rained anywhere near as much. There was a lot of rain that resulted simply because the atmosphere was warmer than it was 100 years ago. There's a lot more moisture that could get rained out. And so that's the thing, though. Precipitation is a measure of climate. And so warming the temperature, global warming, does then have an influence on the other parts of climate. And so that's the reason there's been a lot of transition, I think, anyway, from talking about global warming to talking about climate change. I don't think the hypothesis is there that about, this thing and that thing and what have you. And again, I'm going to go back to his article real quick. He's talked in here about, oh, goodness, No. Where did he talk about it? He talked about... There was somewhere where he talked about the record cold in February, and what have you. And... it's escaping. I can't remember where he started talking about it. Look, I don't think the UN should be stamped with authority on a whole bunch of different things, but that's the way it is right now, unfortunately. Shoot, where did he talk about it? I missed it. Crap. All right. Oh, yeah, here it is. Moreover, many regions of the United States experienced frigid weather in February, which once again disproved the global warming assertion. Right here. That's a misconception. Weather and climate are not the same thing. Just because the climate is changing does not mean cold events will go away. Doesn't mean that they won't continue to happen. So there's things like that here too, that he's pushing a lot of popular misconceptions with respect to climate and climate change. And right there, that's one of them, that weather and climate are exactly the same thing when they are not. Stop doing it. So my overall take, I'm going to wrap this up. My overall take on this, very misleading and very scientifically incorrect in a few places. Ignoring a few things going on here. Some good points in that I agree with him in the sense that you should not just be dramatically focused on one thing, which is, although I will say that, human activities are playing quite a role in the climate change that we see right now and should be considered carefully. And I would like to see communities reduce the emissions of greenhouse gases, but it is their choice to do so. I will not force them. So, with all that, I'm going to wrap it up. This is probably a really long video because I ranted a little bit. I always rant at these kind of things. If you like this, let me know. Leave a note. Like, comment, subscribe, all that good jazz if you like this video. I think that's it. Yeah, that's it for here. If you'd like me to review something like this, give you my scientific opinion on it, and I probably will focus on the science. Like I said, I'm not really interested in focusing on the political aspects of it here, but I'm glad to do that. I will also gladly, if you want me to react to this, I'm going to say you got to go be a supporter on sciworthy.locals.com. That's where this request came from, was from a supporter of sciworthy.locals.com. If you go there and you pitch in your support for a couple of bucks a month, then you can ask me questions like this and ask me to review these kinds of things, because if you are not, I can't review them for you. So please go there, go support that. That'll be linked in the description too, along with all of these other glorious little things that I have for everybody. Until next time, folks, I'm Adrian signing off. Stay curious, my friends.